This is the Orbital Starship Station Mark II, the second iteration in a lineup of space stations designed to assist SpaceX in making humanity a multiplanetary species. If you haven't seen part 1, the link is in the description. OSS-2 presents some significant design improvements that differentiate it greatly from OSS-1, most notably the addition of artificial gravity achieved via the rotational habitat. Due to this feature, OSS-2 has some enormous energy requirements. These energy needs are met by the 10 solar arrays consisting of nearly 50,000 individual panels, situated across the overhead of the station. With an estimated average energy output of 13,250 kilowatts, assuming 20% efficiency, this is over 110 times the energy output of the International Space Station. Excess energy is likely to be stored in Tesla battery units for continuous power to the station when orbiting out of direct sunlight. The integrated truss structure, or ITS, is the largest component of OSS-2, with a length of 900 meters and a width of 424 meters. Constructed from 304L stainless steel, the ITS is similar in design to the previous generation. However, the diameter has increased from 6 meters to 12 meters. The larger dimensions allow for the transportation of next-gen Starships and OSS-2 expansion components to be transported internally rather than externally. This streamlines the manufacturing process. The OSS-2's primary objective is to serve as a refueling and orbital ship manufacturing fulcrum. Therefore, Starship and other spacecraft must easily dock with the station. Initially, Starship would dock with the space station, similar to the ship-to-ship refueling configuration. However, this proved to be impractical for transferring cargo and crew. I have since modified the design to now include a PBB, or Passenger Boarding Bridge. The PBB is a scaled-down version of the ITS, with a diameter of 5 meters, developed to connect up to 16 crew, cargo or tanker Starships to the OSS at any one time. 4 next-generation larger Starships are docked with OSS-2 before embarking on their voyage to the Moon, Mars and Venus. The solar arrays are extended when docked to provide OSS-2 with additional energy. 2 Starships, located either sides of the rotational habitat structure, provide a means of escape during an emergency. Orientated with the engines facing down, explosive bolts detach the emergency return vehicles, or ERVs, from the PBB within seconds. The engines fire, propelling the Starship away from danger. All 4 ERVs have a total capacity of 400, double the required capacity for the entire station. I was inspired by the proposed Voyager Space Station when designing this habitat, so many of the features are incredibly similar. The 200-meter rotational habitat structure, or RHS, is the distinguishing feature of OSS-2. Once fully operational, 2 counter-rotating habitats exert a gravitational force of 0.16 g, similar to lunar gravity. In future videos, we will explore how OSS-2 will evolve to include Martian gravity at 0.37 g and Earth gravity at 1 g. The artificial gravity is generated by rotating the habitat at 1.2 revolutions per minute. Within the outer ring, 200 astronauts reside in 7 quadrants, similar to the decks of Starship. These include a cargo hold, crew quarters, a gymnasium, washing facilities, a canteen or food hall, and a bridge. 4 viewing quadrants are located on each rotating habitat, providing a spectacular view of the Earth below. Rather than wasting valuable real estate, 2 156-meter diameter radiators are fastened to each rotational habitat. Below the deck of the station, heated ammonia circulates through 56 radiators, drawing away excess heat from the station. If you would like to support the channel and play a major role in getting people interested in space exploration, please hit the like button, subscribe if you haven't, and share this video with your friends. This helps tremendously, as the channel is not yet monetized. Once monetized, I can express these ideas through bigger and better videos. Thank you very much for watching. Your help is greatly appreciated, and I will see you next time.